Alright, now let us go to the next part, which is the track record agent. What does the track record agent do? It is going to build and evaluate the sponsor credibility profiles based on their entire history of the behavior across all the studies in the database. Okay. And why does the track record matters? It is a single file, it is a single missing result could be an oversight, right? 5 missing results from the same sponsor is a pattern, right? And this agent sees the full picture across all the sponsors studies, which means, for example, whatever studies are let's say done by Reckitt Benckiser or Novo Nordisk or GlaxoSmithKline, it is going to look at if there is any pattern in all the sponsor studies. Okay. It answers, is this sponsor generally trustworthy? It is going to suggest that is this sponsor really even good enough, or this organization's research are good enough or not, right? So it is going to look at that credibility. Okay, so it is going to work with these tools. It is going to take it from search tools, from clinical tools. That is going to get fetch study details, fetched search studies by condition, agent name and signal type. We have discussed this. These are the agent tools it will be working with. We're going to define the procedural and episodic shared instance here. We're going to bind the agent tools to the LLM instance. We're going to create a track record node. And what does this track record node do? It evaluates the sponsor credibility, and it runs in parallel with 5 other specialist agents. Okay. It is from the procedural instance, we're going to apply get procedures for that particular agent name. We're going to get the procedures, which are the rules. We're also going to extract the text of those rules, and here we're going to define the system prompt, okay, which is your track record agent. For Mosaic, you build and maintain sponsor reputation profile, all of that. Then it is also going to get the reasoning rules. It is going to get the workflow. It is going to get the now this is same for each and every agent. Okay, I'm just going to give you a walkthrough. I'm not going to run through all of it once over again, because it's a waste of time. You just read through this and you will understand what that agent does. Now this particular node, which is track record node, gives you this kind of output: NCT ID, signal type, summary, evidence, confidence interval. From the state, it is going to get the task. It is going to get the NCT ID, then the same human message. It is going to take system message and system prompt. Okay, so sorry, system prompt and the human message. Signal found, max iteration, we're going to loop over it. It is going to look at the tool calls, execute tool call function. We have done all of them. Then it is going to save that particular episode to episodic memory. Okay, it is going to, what is it is going to return? It is going to return the signals as well as which all the agents worked. It is going to log the exception. Then we are going to run the parse signals function, which takes the response text, agent name, gives you a list of signal outputs. Okay, it matches the JSON pattern, and it runs the execute tool function. Okay, so typically this is what this function or this tool helps us understand. Okay, which is if the credibility of the agent is good enough or not. Next is the pattern finder agent. The pattern finder agent broadly does the same job. Again, these are the tools that it is working with. Okay, clinical tools, these many. Okay, from tools.pubmed tools, it is going to use search PubMed tools by query. First and foremost, what does the pattern finder agent do? Okay, it is going to find the cross study patterns that no single human reading one study at a time would ever notice. Okay, so it is going to basically connect the dots. It is going to look at different study and what are the cross study patterns. It is going to look for that. Okay, what patterns does it look for? It looks for same drug being tested by multiple sponsors for the same condition. Why are so many companies testing this? What are they hiding? A drug that failed phase 2 being retried in the new disease area, which is same mechanism. A sponsor consistently running trials in the same condition with consistently poor compliance, and multiple trials from the same sponsor, all missing results in the same year. Now you can see there are so many difficult patterns. Okay, and this pattern, as the name suggests, pattern finder, it is going to look out for patterns and it is going to search for them. Okay, why is this unique? Because pattern detection requires simultaneous awareness of hundreds of studies. A human analyst can deeply follow 10 to 15 studies at a time, and this agent holds 286 studies. So it is going to look at it is going to perform pattern recognition across 286 research studies, and that is what makes this agent powerful. Okay, These are the agent tools it is going to work with. Procedural and episodic instance, we're going to bind the tools here, same job. Okay, then we're going to create a node called as pattern finder node. Okay, going to take the rules or the procedures, going to take the procedure text, we're going to define the system prompt. Okay, then it is going to look at the messages, signal founds. It is going to perform absolutely same thing. It's literally the copy paste of the past code, same code for parsing the signals, all of that. Okay, execute tools, all of this remains the same. It is just the few fields that here and there get changed, but the rest of the part, which is pattern find, it all remains the same. Okay, next is side effect checker agent. Now side effect checker agent, what does it do? It is going to compare what official trial filings say about the safety against what the research papers have published in the same trial. Okay, this is what it gives us the understanding on. Okay, now the official research filings are written by the sponsor, which means the entity, okay, with the most to lose if the safety problems are disclosed. And published papers are written by independent researchers who have no financial incentive, okay, to hide the safety concerns. And when these two sources disagree, that disagreement is a signal. So that disagreement will be looked at by the side effect. Okay. For example, the official filing says that there is no serious adverse events observed, but the published paper says that 3 patients are hospitalized with cardiac events. Now this gap, okay, is what the agent hunts for. Okay. And we're going to set the lowest threshold of all the agents here, which is going to set the lowest threshold, which is 0.55. Okay. All right. Okay, we can see procedural store, episodic store. These are the tools we are working with here. Okay. The agent name is side effect agent. The signal type here is safety gap. Okay, so in signals table, you can just put a where clause basis the safety gap, and you can extract the data. Okay, we're going to create a node called a side effect node. Okay, and we're going to literally perform the same thing. Okay, you can just go through this. Okay, we're doing the absolutely same tasks here again. Okay, execute tool, parse signals. We have literally copy pasted the code. And the last one is the timeline agent. What does the timeline agent do? It is going to detect the studies that are significantly delayed past their own stated completion. Okay, and why does this distinction matters? A disclosed delay, which means a sponsored filed an amendment explaining the extension, which is acceptable. Trials get delayed, that is totally fine, but transparency is the key. So the research sponsor has to be transparent with their research study. Okay, a silent delay, which means a trial is months or years past the complete date, no amendment is filed, no explanation is given, and that is suspicion. So this silent delay, okay, where the sponsor has not given any explanation, this is what our agent, this silence is what our agent needs to spot. Okay, so that is again the thing that we are trying to test here. Again, the same job. Okay, if you literally see, it's literally the same code. Yeah, so I'm not going, as I said, I'm not going to keep on explaining, it's a waste of time. Yeah, so yeah, please read, please go through this, and that was all your agents in place, guys. So you can see there are typically 7 agents that we looked at. Okay, we looked at how supervisor agent works, then what does broken promises do, what does missing results do, what does track record do, what does pattern finder do, what does side effect do, and what does the timeline analyst do. Okay, that's fantastic. All right, let's move with the next part where we'll be building the backend.